Hello, everybody. For the last part of our review here, we take a look at the last 20 questions, 81 through 100. So starting with 81 here, you're asked for the distance between these 2 points. So we'll run the distance formula. From -5 to -9 will be -4, and that'll be squared. From 2 to -4, that will be -6 and squared, and we'll take the square root of the entire calculation. So that'll come out to be the square root of 16 plus 36, which is the square root of 52. If you have to give the decimal approximation, you can just simply grab a calculator. That'll come out to be approximately 7.21. If you're asked to give the exact radical answer, we can factor the perfect square 4 out and turn this into the square root of 4 times the square root of 13 to make the exact form 2 square roots of 13. Just depends which version of the answer you're asked for, the decimal approximation or the exact perfect answer. For 82, we've got one endpoint at 2 comma 13, and you're asked to find the other one given that you know where the middle point is. This is basically a counting exercise. You have 2 comma 13 for A, and you have the midpoint sitting at 10, -1. So you need B to continue the same pattern. To get from 2 to 10 was a trip for 8 steps. So we'll go 8 steps and end up on 18. 13 down to -1 was a decrease of 14 steps. So we'll decrease 14 steps. Point B has to be sitting at 18 comma -15. You can do the algebra from the midpoint formula, but it is a lot faster just to count them. It makes the problem that much easier to do. All right, for 83, the statements and reasons are down here in the table, but I don't want to keep scrolling back and forth on you guys as you're watching this. So we're just going to write the proof off to the side here. We are given the fact that AD is parallel to BC, and that AD is congruent to BC, true facts because they were given. And based off of that, our task is to prove that the top and the bottom also have to be parallel. So let's add to our picture. AD was parallel to BC, and AD was congruent to BC. If we're going to prove the top and the bottom are parallel, we're going to need a couple of angles because you can already see with the diagonal line going across the picture, we're heading towards alternate interior angles. We're building that kind of a parallelogram triangle problem. So let's use the ones we already have. Since these are parallel to each other, we can take angle ADB and make it congruent to the alternate interior one, CBD. So angle ADB congruent to angle CBD. That will be alternate interior angles being congruent to each other, at which point then we could always argue the line the two triangles share in common, DB congruent to BD. Anything that's congruent to itself is the reflexive property. At which point you have these two triangles being congruent to each other. So triangle ADB, we'll just use the same angle names we did earlier, has to be congruent to triangle CBD. And the question is, what have we built in the picture? We had the side from given, the angle that we got from alternate interior, and the side that we got from reflexive. This is side angle side congruency. Now that that's taken care of, I can build the other set of lines. I can always argue the bottom angle and the top angle up here have to match now, because that's going to be a corresponding part. So angle ABD being congruent to angle CDB, because they are corresponding parts of two triangles. I just proved congruent, but notice it's the other pairing of what we have. Now that this angle and this angle up here are matching up, I have proven the top and the bottom have to be parallel to each other for the same exact reason as it was earlier. So AB is now parallel to CD because that's a pair of alternate interior angles that are matching up to each other. If we take a look at 84 next, you're given triangle ABC being transformed into XYZ, and you're being asked to determine if what you have listed here in these three tables is enough to actually prove the congruency. So let's check off what we have. For the givens in the first one, we have angles. So basically the question is the following: is angle, angle, angle a congruency theorem that we know? Which it's not. So, we have and we have two angles and a side. So there's only two possibilities here. It could be angle, angle, side if it's not in the middle. It could be angle, side, angle if it was in the middle. Anything else would be just a version of that, in which case both of these are actually true. So I don't even have to bother drawing a picture to check it. No matter which one it is, they're both real theorems. The last one at the bottom is going to be the only one that's actually some work for us. We have one angle and two sides. Well, the only possibility is side angle side. The question is whether or not that actually matches up to it, because this is the only one that works. If we have two sides and the angle not in the middle, that's not a true fact. So we have to actually draw the picture for the last one and prove that the angle's in the middle. So let's sketch two triangles real quick and see what we've got here. A, B, and C, X, Y, and Z. A matching X, AB matching XY, BC matching YZ. That angle is not in the middle. We don't have side angle side, so this is false. This does not work out. Quick and easy way to check the congruency theorems. Does it even have the requirements? That's why the first one failed right off the bat. And then if it does have the requirements, does it have them in the correct order? Which the second one did, the third one doesn't. See, for 85 and 86, we're going to do these two together. It's the same list, A through I. For 85, it's all the ones that are congruent relationships, while 86 is all the ones that are supplementary. So base angles of an isosceles triangle would be congruent. Corresponding angles from parallels are congruent. The diagonals of a rectangle are congruent. The diagonals of an isosceles trapezoid are congruent. Vertical angles across from each other are congruent. Linear pairs add up to 180, so that one belongs in 86. Alternate interiors from parallel are congruent. Opposite angles of a parallelogram are congruent, but the consecutive angles of parallelogram are supplementary. That belongs over on 86's side as well. So for 85, it should be everything except for F and I, which 86, you should have F and I. Which then brings us to 87. We have three quickie arithmetic problems for each of these. We're going to deal with the mid-segment concept for a trapezoid 3 times in a row. So MN was 32, PQ was 20, and RS is the one we don't know. We'll leave our X there. So X plus 32 cut in half has to equal 20. Remember, mid-segment is the average of the top and the bottom is equal to the middle one. That's the idea. If we multiply the two over, X plus 32 would have to equal 40, which makes that bottom one, RS, equal to 8. Same logic for all three of them. It's going to be the idea. So MN is 20, PQ is X, and RS is 42. So 20 plus 42 divided by 2 must be equal to X. This is direct computation. 20 plus 42 is 62, cut in half is 31. And the bottom one, MN is 22, PQ is X, and RS is 42. So 22 plus 42 divided by 2 equaling X. Again, direct calculation. 22 plus 42 is a grand total of 64, cut in half to be 32. For 88, we have a rectangle, RSUT. We're told that R to X is 4X. S to T, the entire length of the diagonal, is 100. And then X to U is 5Y. at which point we're then asked to go solve for both x and y. The key is realizing that the diagonals of a rectangle have to be congruent to each other, and they also bisect each other. So the 4x is half of the rectangle's diagonal, 50, and the 5y is also half of the rectangle's diagonal, 50. If we divide 50 by 4, we'll get 12 and a half for x. Oops, it's a bad 5. There we go. And if we divide 50 by 5, we'll get 10 for y. All right, for 89, we're asked to find the value of EF in this trapezoid. It's another mid-segment problem, except this time the algebra is a little more advanced. So we're going to take 6 added to 9x plus 5 divided by 2 must be equal to the mid-segment, 4x plus 8. We're going to do 2 steps in one here. We're going to multiply the 2 over, don't forget about the distribution, and we're also going to combine the like terms that are in the numerator at the same time. So 9x was the only x term, but 6 and 5 will be a total of 11. Multiplying the 2 over creates 8x and plus 16. If we subtract the 8x off, that's a single x. If we subtract the 11 off, we get that x is 5. The question does ask, however, for what is the length of EF, so we're going to go back and plug it in. E to F would be 4 times 5, which is 20, plus 8, which is 28. And then for down here at 90, we're given an isosceles trapezoid, and you're asked to find the measurement of the angles. Let's apply isosceles immediately. If the lower left angle is 68, then angle 1 is 68. That's instant. And then 2 and 3 have to be the same measurements, but we have to actually go figure it out. Since we have the parallels from the trapezoid, we have supplementary. 180 minus the 68 would leave me 112 degrees up here at angle 2, and isosceles would kick in again, means I have 112 degrees over here at angle 3 as well. See, for 91, we jump into a kite. We're given that A to N is 2.9 meters. So you're asked to figure out the length of the entire diagonal from A to C. And that's where we use the folding concept of a kite. Based off of the congruency marks, if it's 2.9 from A to N, it must be 2.9 from N to C. And a pair of 2.9s would add up to a total length of 5.8 for the length from A to C. For 92, we're going to use another kite, but this time let's go figure out all the angles from it. One of the first properties right off the bat, the angles that are formed by the diagonals have to be 90s because the diagonals are perpendicular. So angle 1, 2, 3, and 4 are all 90 degrees instantly. And now let's go use the folding concept to help us out. If it's 43 in the top here, then we know angle 5 has to also be a 43. And if it's 37 in the top one here, then we know angle 6 has to be 37. The only real work in this problem is to go figure out 7, 8, 9, and 10, because you have to actually finish the triangle problems out. So up here in the top one, 180 degrees minus the 90 minus the 37 is going to leave me 53 degrees. So that'll be angles 9 and angle 7, because we can use the folding technique again. So same logic, whatever we get for 8 and 10 has to be the same. We're going to do the same exact work. In this triangle here, we have 180 minus the 90 minus the 43, and that leaves me 57 degrees. Excuse me, 47 degrees for 8 and 10. For 93, we go back to segment addition, so all the way back to beginning of the course here. If the entire length from A to C is 72, figure out the length from B to C. So we're going to add the parts up here. If we combine the x's, it's 7x. If we combine the constants, it's minus 5, and that has to be equaling 72. We'll add the 5 over to get 77, and then divide the 7 out. We know the value of x, but the question asked me to find the length of BC. So 5 times 11 will be 55 minus the 8. BC has to be a length of 47 units. And then 94 also goes back to the start of the course. Two angles directly across from each other are vertical and as a result are equal to each other. So 3x plus 10 must be the same angle measurement as 2x plus 15. If we subtract the x off, we get a single x. If we subtract the 10 off, we get 5, and that is all we were asked to do, is just find the fact that x is 5 in that picture. 95, another vertical angle problem, but a little more advanced this time. Same thing though, we know the vertical angles have to be equal to each other. So 6x minus 125 has to be equal to 2x plus 39, which then if we subtract the 2x off, we get 4x. If we add the 125 over, we're going to get 164. If we divide the 4 out, it's going to come out to be 41. Now the question asks to figure out the measurement of this angle here, CAB. So let's go plug our 41 in. You can plug it into either one of them. It's not going to matter. The bottom one's a little nicer on the math. 2 times 41 gives me 82 plus 39 means this angle is 121. So its linear pair supplement has to be the remaining 59 degrees to make it a total of 180 for a straight line. All right, 96 here. We have a ray that intersects an angle, and then we're asked to figure out the value of x. Well, let's use bisect to our advantage. The angle CAT is 30, but it's been bisected, so we have two 15s. And now we can actually use the angle we're given. So 2x plus 10 must be one of the 15-degree angles. If we subtract the 10 off, we get the 2x is equal to 5. Divide out the 2, x must be 2.5. 97 is the same style problem, except instead of being given an actual number that you could cut in half easily, you're going to have to actually go do the algebra. So we're going to do the same exact logic. It's the same setup. Half of 8x minus 30 must be equal to 2x plus 10. It's the same design. Now you have options. You can distribute the 1/2, which in this problem would actually be easy because 8 and 30 are both even, or you can multiply by 2 just to clear out the fraction, which that's the method I will show, because more often than not, you don't always have even numbers, so multiplying by 2 will make your life a lot easier. This problem happens to be really nice because it does have the evens in it. If we subtract the 4x off, we get 4x. If we add the 30 over, that becomes 50. And if we take 50 and divide it by 4, that will come out to be 12.5. All right, the last few here, let's get into a little bit of work on polygon and angle measurements. So for 98, we want to find the measures for an interior and exterior angle of a regular 12-gon. So we'll take 12 minus 2 times 180, and that is the total measurements of all the angles inside the 12-gon. We want to divide it by 12. That way it comes out to each one, because it is regular, so you know they all have to be the same. If you go calculate that out, it comes out to be 150 degrees. At which point, if there's 150 on the inside, linear supplementary argument tells me there must be 30 for the outside angle. 99 is a similar question, but can we work backwards? So we know for a fact, number of sides minus 2 times 180 divided by number of sides came out to be 177.6. So now it's a matter of, let's go do some algebra here. Again, 2 steps in one. We're going to multiply by n. So 177.6 N. But I also want to simultaneously distribute the 180 so I don't have to do a ton of extra writing. So 180 N minus 360. We're going to move the smaller one over. So if we subtract that off, 180 minus 177.6 makes this 2.4 N minus 360 equaling 0 now, because there's nothing left on the right-hand side. We'll add the 360 over. 2.4 N equals 360, and we'll divide by 2.4. 360 divided by 2.4 comes out to be 150. This figure has 150 sides in it. And then last but not least, for the 100, we want to find the measure of an exterior angle for a regular pentagon. Well, as a reminder, exterior angles are a fixed total. It's always 360, and pentagon means all 5 of them are the same. If we take 360 and divide it by 5, each exterior angle comes out to be 72 degrees. And that is everything for the first semester's review. If there's any questions on this part, make sure to ask your teacher, and good luck when you get into the exam.